Okay, so what we're going to do now is we're going to jump onto CE1 and we're going to do a route policy to export its loopback towards PE1 on BGP. So let's bring up the command line and have a look at that. So we're already on CE1, so let's have a quick look here at show route. So it's got its own internal BGP routes, which is fantastic. Okay, so 13, 13, 13, 13, 12, 12, 12, and 11, 11, 11. That's great. So 11.11.11.11, that is from protocol direct. So that's directly connected. So that's what we're going to deal with first. So let's go into configuration mode. And let's do set policy options, policy statement. And we're going to call this, say, loopback. And we're going to do term 1. And it's going to be from protocol. And the protocol is going to be direct. And now it's going to be term 1 from route filter. And it's going to be 11.11.11.11/32 exact. And then the then statement is going to be accept. Fantastic. And let's see what we've got. So we've got our policy statement for loopback. If it's from the protocol of direct and it matches exactly 11.11.11.11, then accept. So what we need to do, we now need to apply this as an export policy to the BGP group. So set protocols, BGP group, question mark ext. And if we do another question mark, we should have the export option there. See, as you see above family, we have export right there. Fantastic. So we're going to do export. If we do another question mark, we've only got the one policy that we've created, so that's loopback. And now let's do another show pipe compare. Fantastic. So we can now see that under our BGP session for the logical group, for the group external, we've now got our export loopback, and of course we have our policy option as well. So let's commit that and quit. And let's do a show BGP summary. Sorry, let's do a show BGP neighbor, my bad. And we scroll down to the bottom, and as you can see now, our advertised prefix are actually now shown as 1, whereas before that was 0, because we're now advertising via BGP the loopback address. So let's have a look on PE1, see what's on that. So let's do set CLI Logical Systems PE1, and let's do a show route receive protocol BGP. Oops. And the peer address is 172.16.1.111. Excellent. So as you can see, we're learning from our peer the 11.11.11.11/32, and we can see its AS path is coming from 65001, and its origin code is I, so it's an internal route to that particular device. And you can also just do a show route protocol BGP and again it shows us exactly the same information. It shows us the actual route that we've received. It shows us the protocol that it's on, its administrative distance, which is 170, and what's the local preference is at 100 by default, and it shows us the AS paths it's gone through, 65001, and then internal, and it shows us the actual link that we need to get there. So we've learnt it on from 172.16.1.111, which is the CE1 address, and the interface that we receive that we use to get to that address is Logical Tunnel 11. Fantastic. All right, so we've managed to propagate that route. So what we expect to see now is, as we know how BGP works, is we've now got the route going into P1, and how BGP works, as we said earlier on, is that BGP will then forward that onto other BGP neighbors. So we should be able to see the 11.11.11.11 route on all the other BGP devices. So let's have a look. So we'll have a look on PEs2 and PEs3. Let's bring back up the command line. So set CLI Logical Systems PE2, and let's do a show route protocol BGP. Okay, so we've not seen it. That's very, very, very strange. Now what we can see though is we can see that we have a hidden address. So let's have a look at hidden. Okay, so now we can see that we have the route, we've received it, the 111, the 11.11.11. We've received that prefix via BGP, and we've received it from PE1, so 1111. However, the reason that we can't use it, or it's not in our table, is because it's unverified. Now what we seen earlier on when CE1 advertised the route to PE1, that was all well and good. You know, PE1 knew where it came from. However, PE1's now advertising this network off. So PE1 has gone, okay, if you want to, let me get my pen up, if you want to get to here, to the loopback, so this is what he's sending out, as what's going everywhere. So if you want to get to there, this is the address you need to use. However, that's the next hop. Now that's a problem, because these devices have no idea how to reach that address. What's supposed to happen to overcome this is that we need to do another policy filter to turn around and say, if you're advertising out BGP routes internally, change the next hop to yourself. Once we do that, then the other routers will be able to use that particular route. But as it stands at the moment, the route can't be used because they don't have any route to the 172.16.1.111. So let's bring that up again. Right, fantastic. So what we need to do, like I said, we need to change that on PE1 to say, right, next hop self for us. So let's go back onto PE1. So set CLI Logical Systems PE1, and let's do configuration, and let's do set policy options, policy statement, go and call it next hop self at NHS, term 1, then next hop oops, self. Nice and easy. Show, compare. Okay, so all we've done a policy option. We've called it next hop self, but you call it anything you want, and it's just a basic term one, then next hop self. So what we do, we'll apply this now to the internal, the internal BGP as an export policy, and that should fix the ability, the reason why the other PEs are not seeing this particular route. Why? Because at the moment it's hidden because they don't have a route to the actual next hop, but they will when this is automatically changed. So set protocols, BGP group, the question mark, groups we've got is internal, and you're going to do export, the question mark, next hop self. So commit and quit. Just wait for that to go through. Excellent. Now let's go back onto PE2. So set CLI Logical Systems PE2, and now do a show route protocol BGP. Fantastic. And as you can see, we no longer have any hidden routes there. So the hidden routes is none. We actually see the route there. However, it's telling us now that to reach that this route is reachable via this address, the 10.10.12.1, which is the interface between PE2 and PE1, as it says there, via logical tunnel 2. So prior to that, what was happening is because the next hop wasn't updated on the IBGP peering, then what was happening was it was attempting to use the logical tunnel 11.11.11, which is the CE3 address, which is the CE1 address, which is absolutely of no use. But now we've put that policy statement in to say, right, any BGPs routes that you send out, change the next hop to yourself. So now that will work fine for any particular routes that we have. Okay, so let's have a look now on, let's do set CLI, oops, so set CLI logical system, and we've got P3, and let's do show route BGP, show route protocol BGP, I should say, BGP. There we go. We have the 11.11.11.11 as well, so that's fantastic. And lastly, let's check PE4. So set CLI logical system PE4, and let's do show route protocol BGP, and we don't have it. That's very strange, isn't it? So we don't have the route, and we don't even have it in hidden. Now why would that be? Okay, I'll let you know why. Okay, so the problem we have with IBGP for loop prevention is, while we can send out in this direction, that's fine. So you can send a BGP learned route to one of your BGP neighbors, that's fine. But on IBGP, that router cannot then forward a BGP learned route to another IBGP neighbor. So while routers 2 and 3 are fully able to take the route from PE1, neither of them are allowed to forward it to PE4. They're not allowed to do that, so it's automatically blocked, and consequently PE4 is never going to learn any of these routes, and therefore none of these in area 4 will ever be able to learn the routes either, and of course that's not what we want with BGP. We want to be able to share routes, you know, across everywhere, and vice versa. If we have, when we do later our BGP session here and we advertise out, this will receive the routes, this will receive the routes, PE1 consequently won't receive the routes, and of course neither will any of these. However, if we, once we have our BGP set up here, this will receive the route because this is an IBGP relationship, and the same as here and here will send the routes, because this again is IBGP. It's only the IBGP which is the problem. So you can only send BGP learned routes to one hop away on IBGP neighbors. After that it can't go. So we can get around that mainly by doing a couple of different methods. We can have a full mesh, which means that these have direct BGP peerings with each other, which we can do quite easily because we have the loopbacks learnt via OSPF or ISIS if you're still using that. We can set up a BGP neighborship absolutely fine. So an IBGP neighborship between the two of them absolutely fine, and that will resolve the problem. And for a lab of this size, which is only like 4 or 5 routers in your core, that's not a problem at all. It's not going to cause any issues whatsoever. However, once you start scaling up your topologies and you're dealing with, you know, like in a normal provider network, 20, 50, hundreds of devices, having a full mesh topology where every device is connected to every other device becomes burdensome, and it uses a lot of network resources and a lot of bandwidth, and it's too much of a headache to actually work. It doesn't scale well. So what you would do then is that you would have a core router as a route reflector. So what would happen there is that instead of peering with each other, all these devices peer with the route reflector, and the route reflector's job is then to push all the routes out. We'll have a look at that in a later video of doing a route reflector rather than a full mesh, because full mesh is just boring, and you know, it's an easy way out really. I mean, just set a neighborship up there and that problem's solved. We don't really want to do that. So like I said, we'll do route reflector later on. Prior to that, we need to obviously configure the rest of these areas and get BGP flowing back and forth, and see where we're up to with that. All right, so I look forward to seeing you in the next video.